Okay, for this video AI, we're going to look at how we can use the Excel solver to help us find the best fit model. And this is going to be particularly useful. There are some times where when we try and solve exactly for the parameters in Mathematica, we're going to run into difficulties. And if we can't solve for the parameters exactly, then we can use the Excel solver to get us the best fit model that's going to get us this, the highest R squared that we're going to be able to get for the model that we're trying to fit. Okay, so for this problem, we're given that we're a platoon leader in Afghanistan, and we're trying to build rapport with local elders by producing the perfect cup of chai. So our interpreter has given us the ideal methodology, and it includes heating water to 170 degrees Fahrenheit, steeping the tea leaves at this temperature for about 7 minutes, and then bringing the water to a boil. So you are recording the water temperature in degrees Fahrenheit over time and minutes as your interpreter makes the pot. And you want to create a model of that data so that you can replicate it. So here's the data, and the first thing we're going to do with a situation like this, I could look at the data and try and picture in my mind what it looks like and try and think about what the best model would be to fit it, but I have trouble visualizing just numbers, so I'm going to plot the data. Unfortunately, you don't need to recreate the data. You can just open up the Lesson 49 Video AI data, and here it is right here. So I'm going to take this data, I'm going to select the data, and I'm going to insert a scatter plot. Okay, now that's a lot easier to visualize, and I can see that this looks to me to be a power function. And maybe I've forgotten exactly what type of power function would best fit this data, so I'm going to check in my textbook, and here's my power function. I know that y is equal to some parameter a times the quantity x minus another parameter c raised to the b power plus d. Okay, now remember that there are some cases of these power functions. They're all based on the b value. So we had case 1 where b is equal to a positive integer. And I look at the shapes of these, and already that looks promising. This one on the left does not look promising because my data does not have this parabola shape, but this one actually does look pretty promising. My data does have this S shape, and let me check the inflection because I remember that case 2 also has an S shape, but you'll notice that the inflection on it is curved downwards on the right side of the S, whereas with the case 1 the inflection is curved upwards on the right side of the S. So let me look at my data again, and yeah, on the right side of the S I seem to have that upward curve. So I believe this is going to be a case 1. So already I'm going to start estimating my parameters before I ask Excel to help me solve for the best parameters. So I'm going to pick my b to be an integer, and again I said this parabola does not look right, and that was the case where my b value is an even integer. Instead I want this S shape, which is the case when b is an odd integer. So I'm going to start with b equal to 3. Now C referred to my vertical or my horizontal shift, and I look at this data set and it looks to me like my point of inflection, that would be right here in the middle of the graph, is shifted right somewhere between 10 and 12 or so, but we'll call it 11 to start and see how that works out. My D is my vertical shift, and again I'm measuring from that point of inflection in the middle, and it looks to me like my vertical shift is somewhere between 150 and 200, maybe about 165. And my A parameter I remember that stretches or compresses the function along the vertical axis, and it's hard to estimate the A parameter just by looking at it initially, but I'm going to leave it at 1 for now and see how that looks. Okay, so I've got my parameters estimated for my power model, which again, my power model is this function right here. And now I want to get my estimates for what would be my dependent variable or temperature as a function of my independent variable, which in this case is time. So I'm going to come back here and I'm going to get my estimates based upon my model. So this is equal to A, and I want that to be an absolute cell reference, times the quantity, my x value, which again is time, minus my c value, again, that's an absolute cell reference. Close those parentheses and raise that quantity to the B power, and then add my D value. And again, both B and D are going to be absolute cell references. Okay, so I'm going to take one last look at my function, make sure I'm entering the correct equation, and it looks good to me. So I hit enter, and there are my estimates. Looking at them originally, when I look at it for time 0, my estimate of negative 1,166 looks nowhere close to 72, but instead of just looking at these item by item, I'm going to throw these on the graph. So I could delete this graph and make a new one, selecting all 3 columns for my data, or I could right click on this and say select data. Okay, and I want to add data to my chart, so I'm going to click on the add button, and the name of it is estimates. The X ranges are going, or the domain of my function is in my A column from 0 to 20, and my Y values are in my C column, which are my estimates. Click on OK, and now I've got my estimates on there, and I don't want those data points. I want this to look like a line. So I'm going to select, I'll right click on one of the points and go to change series chart type. Now I'm going to click on this line in the XY scatter. Click on OK. Now I've got this nice line that is a little bit easier to visualize, the line versus the data points. And I can actually see that I've married up my point of inflection pretty well right here with my horizontal shift of 11, my vertical shift of 165. My B parameter seems to fit the shape of the data pretty well, but I need to compress my data. So my A value of 1 was too big, so I'm going to try 0.5. 0.5 is still too big. I'll try 0.25. Still too big. 0.1. That's getting pretty close. I want a little bit less than 0.1. Let's try 0.05. That was too much, so let's try 0.06. And that doesn't look too bad. It looks like I've got a decent fit. I could probably find a better model, and I could play with my A, C, and D parameters to try and see if I could get something that would visually fit the data better. But I'm pretty happy with the visual fit at this point. So let's look at a more objective measure, and to do that we're going to look at the sum of the squared errors. So to get my squared errors, I'm going to take my estimates minus my observed temperatures and square each of those values. And then the sum of my squared errors, or my SSE, is going to equal the sum of those values. So I use the Excel function sum, open up parentheses, select all my squared errors, and there's my SSE, about 997.15. Now, I can use the Excel solver to minimize my SSE, which will ideally give me the best R squared. And to look at our R squared, we can go ahead and put in our SST as well, so that we can calculate R squared. So I'm going to need my squared totals, and to get my squared totals, I need my mean value. So I'm going to make a little cell here for mean, and I'm going to set it equal to the average of all my actual data points. So I can use the Excel function average. I select all of my temperatures, and there's my average temperature, 156.3. And I remember my squared totals are the difference between my actual temperatures and my mean value squared, or my mean minus my actual temperature squared. So I'm going to take my mean values, I want that to be an absolute cell reference, minus my observed temperatures squared. Drag that value down, and those are my individual square totals. So to get the sum of my square totals, it's going to be similar to getting my SSE. Just going to use the sum function, select all of my square totals, and there's my SST. So now I know that my R squared is equal to 1 minus my SSE divided by my SST. So just based on eyeballing it, I've gotten an R squared of about 0.95, and it looks to be pretty decent, but I would like to see if I can get a better model. And again, I don't want to do it by constantly trying to manipulate 3 different parameters. I could spend a long time playing with the 3 parameters and trying to find out exactly what's going to get me closest. So instead I'm going to use Excel Solver, and to do that I'm going to click on Data, click on Solver, and I'm going to set my target cell. That's going to be the cell that I'm going to try and maximize, minimize, or whatever the case may be. I want to minimize my SSE, so I'm going to click on this cell H6 and click back down on this down arrow, and now I can see that my target cell is H6 right here, which is my SSE, and I want to minimize that, make my SSE as small as possible so that my R squared can be as high as possible. So I make sure that that minimize radio button is clicked, and now I need to tell Excel what values it can try and manipulate in order to minimize my SSE. So the values I want it to change are my A, C, and D, but the actual numeric values. So I'm going to click H1, which is my A value. I'm going to hold down Control and then hit H3 for my C value and H4 for my D value. Now Excel could try and manipulate my B value for me as well, but based on the cases that are in my textbook, I want to leave B as an integer. And if I let Excel change it, it would probably not leave B as an integer. So I'm just going to leave B as equal to 3 and see how that works out for me. Okay, so now Excel knows that it's going to try and make SSE as small as possible by changing my A value, my C value, and my D value. So all that's left to do is click on Solve. And I can see by looking at it, it has indeed changed the shape of my line, and my R squared has now gone up to about 0.9967. And my SSE dropped significantly down to about 68. So that seems to be a better fit, and I can see that it did slightly modify my A value, my C value, and my D value, and it probably would have taken me a long time to use guess and check to get values that were that close. So now Excel's asking me, do I want to keep the solver solutions or go back to my original values? Well, I like Excel's values better, so I'm going to let it keep the solver solutions and click OK. Now I'm going to run this one more time because Excel uses a numerical method to approximate the best solution, and sometimes if you run it more than once it will find a better solution in subsequent iterations. So I'm going to click Solver again, and I notice that it's maintained all the correct data. It's trying to set the target cell as my SSE, which is an H6, by changing my cells A, C, and D, which are in H1, H3, and H4 respectively. So I'm going to click on Solve again, and I notice this time my R squared did not change at all. That indicates to me that I'm pretty happy with my model, and that using the solver subsequent times is not going to help me get a better R squared. In fact, an R squared of 0.996 is really good. My model seems to pass the eyeball test, passes a common sense test, and so I'm happy to say that these parameters for A, B, C, and D are going to give me the best fit line to predict or to match my temperature for brewing chai as a function of my time.